Welcome everyone. I am Ujjwal Pal. Today we will solve the LeetCode problem step by step. The problem number is 2418, which is sort the people. Let's see the problem description. You are given an array of strings, names, and an array heights that consist of distinct positive integers. Both arrays are of length n. Okay, and for each index I, names I and heights I denoted the name and height of ith person. Return names sorted in descending order by the pupil height. So we are given two arrays which have the size n, which have the length n, in the names and the heights. And the ith index, name size is the name of the ith person, and height size is the height of that person. And we have to return a uh, string array of names in descending order by heights. Okay, so let me discuss you the algorithm which I am going to use here. So let's say uh, we have two we have names and we have heights. So what we will do, first we will sort the heights in descending order, as the answer says that we need to return the pupil's height in descending pupil's name by pupil's heights in descending order. So we will sort the heights in descending order, then we will check what is the maximum element and uh, the corresponding name. How we will do that? First, we will create a priority queue and we put all the elements of height in that priority queue, and that priority queue will be max priority queue. So the top element of that priority queue would be the max element of this heights. So first, we will take the top element and we will check and we will also add the priority queue, the index and the value of heights. Okay, like 180 with index 0, 165 with index 1, 170 with index 2, like this. And when we get the top element, we also get the index of that element. So we know the highest element, current highest element, and that index. So what we will do, we just put that index name, the name which is on that index, and we will add the name in our answer array. So like this, we can get the answer array of strings and we can return that. And we do not have, like, see the constant, the consist of letters, all values of heights are distinct, so there will not be any two numbers of two people with same heights. So we can use that uh, in our problem, because if two peoples have the same height, so they might like have two names in, like, for two, if there is two, see, 165 two times, so 165, only 165 have two indices. So there will not be like 265 165 two times. So let me see you the visually what how I will use the priority queue. So let's see, the heights are 180, 165 and 170. The first one, 182 will be added in the, this is the priority queue, and max priority queue. So maximum element will be the top element. So first 182 will be added at the top as a top element. So 180 is added. Second, 165 will be added here, but 165 is not the max element. So what we will see, 182 will goes up and 165 will goes down. Now the next element will be 170. So 170 will, like, go there, but 170 is not the highest element. So 170 goes down and 180 would be the top element. This is the top element. This is the top element. This is the top element. So what we will do, first we check 180, and with the index we always have the index of 180. So we will also have like 180 with 0, 170 with 2 index, and 165 with index 1, like this. We will take 180, pop it out, and 0, the name in the 0th index we will add it in our answer array. Okay, let's see how the code works. First, we will create a max priority queue. So, priority queue and pay up income to queue, and we will add all the elements for equal to 0 and less than height size I plus plus to queue dot push. First, we will add the heights of I, and second will be the index, which is I. So now we have the priority queue, and we first make a vector of string. That's our answer string, answer array, answer, and we check uh, until our priority queue is empty, is size, the queue dot size is present. That means the priority to have at least one element now. So what we will do, first we pop the top element. So auto IT equal to, not IT, let's say current, equal to qq.pop, and qq.pop, and we add in our answer vector is back the index. Uh, we have the index at current dot second. So we have the index. We'll add names of current dot second. Okay. Now we'll have the name with that value of height, and the names will be sorted in descending order of pupil height. Okay. Now we can return the array, our answer array. Let's see, will it work? It's taking so much time. Let's submit. It's accepted. Let me discuss the time and space complexities of this algorithm. So we are using a max priority queue. So in max priority queue, to add each element in the max priority queue, it takes log n time, and we are adding all the elements of height. So which this for loop will take O of n log n time. N is for all the elements, and log n time for each of the element to add it to the max priority queue. And for this while loop, we are popping all the elements from priority queue and adding it to the our after processing. This body of this while loop will take constant time, and this while loop we are popping all the elements, so it will take big of n time. So overall time complexity will be big of n log n. So, and what will be the space complexity? We are storing all the elements of height and all the elements in the names. So, overall space complexity will be big of n. So, time complexity is big of n log n, and space complexity is big of n. So, that's it for today. See you in the next video.